Hello everyone. So today we are going to cover validate stack sequences. We are given input of two integer array pushed and popped, and we have to return true if and only if this could have been the result of a sequence of push and pop operations on an initially empty stack. So let's understand this problem statement with an example. Here is a given example. As we all know, in a stack, what does a push and pop mean? Push is nothing but inserting the element to a stack, and pop is removing the topmost element from the stack. So let's start iterating this. Pushed first, because we are going to push first the elements 1, 2, 3, 4. Now in popped, the first element is going to be 4. So first we are going to remove 4, and then we are going to put 5 here in our stack. The second element in the array 2 is 5, so we are popping 5 again, and then moving on to 3, and then 2, and then 1. Finally the stack is empty, so which means this is the popped array of the pushed array given. We have to return true. So how do we approach this in code? Let's have an external memory stack to do this operation. We are going to push our first element to our stack and check if the first element in popped is that element we pushed, because if it is there in the popped, we have to pop it. No, 1 is not equal to 4, so we are moving to the next number and pushing that to our stack again, and check whether the first element from the popped is 4, the element we pushed, or not. No, it is not same. So we are moving on to the third value and again push it to stack and compare whether it is in popped first. No, it is not there. So finally we are going to push 4 and check whether it is there in the popped. Yes, the first element is the popped is 4, which means we can understand that the first element popped from the stack is going to be 4. So we are also removing that element from stack. So again moving on to our next element. Now our pointer points at the 5 here in the second array, that is the popped array, and in pushed array we are going to point at our last element 5. So we are going to push 5 and check whether it is there in the popped. Yes, it is there in the popped, which means we popped 5 next. So we are again going to remove 5 from the stack. So now our element points at top of the stack, which is 3. We are going to check whether top of the popped array is going to be 3. Yes, it is 3, so we are going to remove 3 as well. And the next element it points here is 2, and again the popped element's top is going to be 2, so we are going to pop 2. Finally it moves to 1, and the last element in popped array is going to be 1, and we are popping 1 as well. Now our stack is completely empty, which means all the elements we pushed to stack is popped, which means they both are the pushed and popped operation of an empty stack. So we are going to return true, which is a pretty simple and straightforward algorithm which gonna use linear time and linear space. So here the question is, how do we do it in constant space? Of course we have to iterate both the arrays in order to find whether they both are pushed and popped. So definitely it is going to be working in linear time, but we can do this without the help of an external stack and make it work in a constant space complexity. So how do we do it? So now we have both of our arrays pushed and popped. We are not going to use the external memory stack. Instead, we are going to use the existing array pushed to perform the operations. So now let's start having two pointers. Pointer I points at push and pointer J points at pop, and every time we pop an element, pointer J moves because it is pointing the numbers or elements which are popped, and every time we insert an element or push an element, pointer I moves. So now we are going to push the same value as that of the array pushed to the same array. So let's see how it is going to work. Now our pointer I is at position 0. We are going to assign the value of position I to the same place. That is, we are going to put 1 in the same index of pushed array. So now we have pushed 1. We are going to check whether j is pointing 1, because j is going to point at the element, what element we are going to pop from the array. So right now j points at 4, which is not equal to 1. So we are going to iterate our I to 2. So now we are going to push the same element to the array, that is the array value becomes 2 again, and we are going to check whether j points at 2. No, j doesn't point at 2. So we are going to move our I to 2, this is 1, and we are going to again push 3 to the same array and move the pointer I to 3. So now moving to our index I is equal to 3, we are going to push 4 to the same array and then move our pointer to 4th index and check whether it points 4. Yes, here when I is equal to 3, the top element in push was 4 and j points at 4. In this case, we are going to move the pointer j to the next element, which means we popped 4 from the pushed array. And what is going to happen to the push array? Push array is going to assign the value of index 4 to index 3, because we popped it, so it deserves to have the next top value inside the push array. So in this case we are going to remove 4 and assign the value of 5 here to the array, and now the index of I becomes 3. It came back to the same place where it pushed. So now it is checking whether j points at 5 or not. Yes, j points at 5. So in this case we have to remove 5 from the array. So what are we going to do? We are going to move our j pointer to the third element, since we have popped 5, and what it is going to do, our I decrements and move to the previous pointer. Now our I is equal to 2 and the element at I is equal to 3. And we are going to check whether j points at 3. Yes, j points at 3. So we are going to move our j to the next element and decrement our I to the previous element. So again it points at 2. So we are going to move j to the last element, pop it I now decremented to 0. The iteration ends, pop array is empty. So we have finished our iteration and we decremented I to finally 0, and 1 is also popped. If I is equal to 0, that is I completely reverse iterated to the starting of the push element, which means all the element in push are popped. In this case it is true. So this will help us not to use the external stack and complete the operation in given push array itself, and obviously works in constant space. So now let's see how we're going to code it. As I said, our first solution is going to use a stack, and I'm going to have an iterator. So first I'm going to push all my elements from pushed array to my stack. Once I have pushed, I'm going to check whether it is the top element in my popped array. That is, if stack is not empty, and the top element at stack is the first element is pointed at the popped array. If that is the case, then pop it from stack and move the pointer I to point next element at the popped array. So finally we have to return if the stack is empty. The stack is empty, which means all the elements are that pushed have been popped from the array. Let's run. This actually runs in 2 milliseconds and the memory is 57.62% faster. So let's see our second solution. So here we are not going to use our external stack. Instead, I'm going to use two pointers, I and j, which is going to point at push and pop. So I'm going to iterate my push, and instead of stack, I'm going to push that to my same pushed array. So once I've pushed, I'm going to check whether my element at pushed, the last entered element at pushed, it is equal to the first element at popped. Since we iterated I once we inserted the element, I'm going to check the value at I minus 1 is equal to value at popped of j. So once if it is equal, then we are going to decrement our I and increment our j. And finally, we have to return if I is equal to 0. It is nothing but the same concept, but instead of using a stack, I just have a two pointer. I points at the pushed array and j points at the popped array, where every time I push my values to my pushed array, I'm gonna check whether the last inserted value is equal to the element or the value at the top of the popped array. If that is the case, we are going to pop it. So instead pop function in stack, I'm just going to decrement I, that just point one element before the actual element, and increment j to point at the next element going to pop. So finally, if my I is equal to 0, then my pushed stack is completely empty and all the elements are popped. So yes, let's submit this code. This actually runs in 0 millisecond because of not using stack, and the memory also have improved. So thanks for watching. You can find the code, both the codes in my link given in description. If you like the video, do like and subscribe. Thank you.